Today we're looking at notes over Systems of Equations Applications Day 2. For the given problem, define variables, formulate a system, solve, and check your answer for reasonableness. So here's our example. At a college production of Streetcar Named Desiree, 400 tickets were sold. The ticket prices were $8, $10, and $12, and the total income from ticket sales was $3,700. How many tickets of each type were sold if the combined number of $8 and $10 tickets sold was 7 times the number of $12 tickets sold? That was a mouthful. So my question being posed is, how many tickets of each type were sold? Okay, so how many tickets of each type were sold? So what were the types of tickets? So the types of tickets were an $8, a $10, and a $12 ticket, and we don't know how many. So there were 3 types of tickets. So we would have 3 variables. So just for sake of ease, we'll use X, Y, and Z. So this situation is a situation unlike the situation we were dealing with in Applications Day 1, where on Day 1, one of the variables was dependent on the other. In this case, none of these are dependent on the other. They're all independent variables. So the number of $8 tickets doesn't depend on the 10 or 12 and vice versa. None of the amounts depend on the other. So these are just independent variables, each on their own. So X will be our first variable, and we will say X will be the number of $8 tickets sold. So we don't need to worry about independent and dependent because they all are just independent of each other. So, and notice I put number here because what we don't know is how many. Okay, so the second variable will be Y, and we'll say that Y is the number of $10 tickets sold. And then Z will be the number of $12 tickets sold. Okay, so remember, like we talked about before, if you've got 2 unknown variables, then you would have to have 2 equations. In this case, we have 3 unknowns, 3 variables, so we must have 3 equations. So what will our 3 equations be? Well, if you read that first sentence, at a college production of Streetcar Named Desiree, 400 total tickets were sold. So that means the combined number of $8 tickets, $10 tickets, and $12 tickets equaled 400 tickets. So that right there would be your first equation. Number of X, number of $8 tickets sold, plus Y, the number of $10 tickets sold, plus Z, the number of $12 tickets sold, equals 400 total tickets sold. Okay, the second sentence will help us with that second equation. The ticket prices were $8, $10, and $12, and the total income from ticket sales was $3,700. So it costs $8 for the ticket X, each of these tickets sold, plus $10 for each of these type of tickets sold, plus $12 for each of the Z type of tickets sold, and the total sales was $3,700. So that's our second equation. Now our third equation is going to come from that third sentence. How many of each type of tickets were sold if the combined number of 8 and 10 tickets sold, so the combination of these, X and Y, was 7 times the number of $12 tickets sold. Okay, so the combination, so when you combine 2 things, that means adding. So the combined number of 8 and 10, so when I combine the $8 tickets, so X, with the $10 tickets, Y, when I combine those 2, it was equal to, it says right here, was 7 times the number of $12 tickets sold. So that's Z. So then I've got my three equations, so then I'm going to use these steps for solving. So steps for finding solutions to linear systems of equations in the calculator, and in this case, unlike Apps Day 1, when the equations are in standard form. So most of my equations are in standard form, all but this one. So we're going to quickly move this last equation here into standard form. So I'm going to move over the 7z. So then my new equation would be x plus y minus 7z equals, now there's nothing left on the right. So now my equations are in standard form. So then I'm going to press second matrix. So I've cleared my calculator. So second matrix right here. Okay, second matrix. Scroll right once to math. Scroll up to B, RREF. So scroll up to B, RREF, and hit enter. Press alpha zoom. Select the dimensions of the matrix, then press OK. So the matrix I'm going to make from this equation is as follows. From these equations are as follows. So hopefully you remember matrices from Algebra 1. So you look at the coefficients. So the coefficient here is 1, 1, 1. And then 400. And then 8, 10, 12, 3,700. 8, 10, 12, 3,700. And then remember, I'm not looking at, I'm going to lightly cross out this. I'm not looking at that equation. That one wasn't in standard form. This one was. So 1, 1, negative 7, 0. That's what your matrix should look like. So what's the dimensions? How many rows do I have? That's what it's asking me. Well, I have 1, 2, 3 rows. So I'm going to scroll up and highlight 3. And I have 1, 2, 3, 4 columns. So then I'm going to hit OK, like it said here, then press OK. Type the matrix values into the calculator. Be sure to use the arrows and not enter. So I'm going to type the matrix values 1, 1, 1, 400, 8, 10, 12, 3,700. Oops, not 37,000. I hit delete then. And then 1, 1, negative 7, 0. Okay. Type them in to be sure arrows not enter. Once your values are all typed in, press enter. So I'm on number 7. Once your values are all typed in, press enter. So enter. The column on the right represents the coordinate of intersection. So the column on the right, the 200, 150, and 50. So that right there is the X, the Y, and the Z. So my point of intersection is 200, 150, 50. 200. And yes, there is such a thing as an X, Y, Z point. So this is X, this is Y, and this is Z. And remember that came from the calculator. So what I would never want you to do is leave your answer like this. What I want you to understand, this represents the point of intersection, just like we did on the Apps Day 1. Okay, so we didn't leave our answer on the Apps Day 1 as just a point of intersection. You take that point and then you give your answer. So the question was, how many tickets of each type were sold? So then you would say $208 tickets sold. You would say 150 $10 tickets sold. And then you would say 50 $12 tickets sold. That would be your final answer. Of course, units on every answer, not just a naked answer of 200. Well, 200 what? I don't know 200 represents. So make sure your answer looks like that. Now let's check for reasonableness. Is this a reasonable solution? Well, yeah, because look here, this is clearly 400 tickets were sold total, and that's what it said before. If you take this number, multiply it by this number, multiply it by this, and this number, multiply it by that, it would hopefully, once you add that up, get to 3,700. That seems about right, okay, because that was the total revenue. So this right here is a great answer. It looks like it makes perfect sense based on the scenario.